This question is definitely overwhelming if you do not have a solid math foundation. This just feels like complete gibberish. I get that. But there's actually not that much we need to memorize in order to get this. It's really just asking about vertex in a complicated way. And so if we study for the SAT, we're going to come across all the different versions of quadratic equations, and this version should very quickly kind of clue us in to the idea of a vertex. It is the vertex form, and so it's telling us something about that turning point of a parabola. So we're going to graph a little bit. So let me draw just quickly a kind of xy plane. Now, we're being told where the vertex is, and normally the vertex is HK. We got to be a little careful here. So what I would do, just to kind of simplify things and understand them better, is when I normally have a vertex equation, I don't have an H or a K. I have numbers in those places. So let's put numbers in there. They tell us that H and K have to be positive constants. So why don't we just make them 2 and 2? Let's just see what's going on with some simple numbers, and I don't know, maybe it'll help. So now I would rewrite my equation as negative x minus 2 squared minus 2, okay? Now, if we know how to read the vertex equation, then this term here is going to be the x-coordinate of the vertex, and this term here, including the sign, is going to be the y. Now, the problem here is that the negative is built into the formula. So when we have this x term, we have to kind of reverse the sign of what it is, okay? So this means then that the vertex, based on this equation, let's put it up here, would be positive 2, negative 2. Okay, that is the vertex based on the numbers I picked, but honestly, based on any numbers that I would pick, my vertex is going to be somewhere in the fourth quadrant, right? So 1, 2, 1, 2, negative. There it is, 2, negative 2. So it's somewhere in that quadrant. Now, they're asking us how many x-intercepts there are. And that could change depending on how we would draw this parabola, right? So if it goes up, there's going to be 2 of them. But in this case, we know that it actually goes down. And we know that because of this part right here. This is sometimes called the A term, because normally there's maybe a number with that negative in front. And there is a number there. We don't write it because it's a 1, but it's there. And so if that A term is negative, we have a frowny face parabola, one that faces downward. So here, there's no way to draw this parabola with this vertex and this direction. There's no way to draw it where we're going to ever have any x-intercepts, right? It's never going to cross my x-axis here. So it's always down. Now, different values of h and k are going to move that vertex, but it's always going to be in that fourth quadrant because it's just where the x-coordinates are positive and the y-coordinates are negative. So there's no other number that's going to move it somewhere else across the x-axis. This can be really hard to think about. So this is a high-scoring question, right? If you're just barely remembering how to factor, this is not for you. But if you're in that kind of like 580 range, 620 range, this is the kind of thing you could definitely get right. This is all about memorization. There's some easy concepts that are normally very basic, just about reading an equation and taking something away from it. Basically an equivalent of like y equals mx plus b, where we know the slope and the y-intercept, except with quadratics, there's more to know. And so there's more equations, more things to learn, but it's just as predictable. And then when they do this stuff with variables, if you have trouble picturing what's going on because there's some sort of unknown, see if you can pick a number. See if you can put a number in there and make it known and see it in the flesh here to see what that graph is actually going to do. This is very, very tough, but hopefully now it makes more sense.